This is Unit 8, Video 6, Double Angle Identities. There will be another video following this that you need to watch called Video 7, Half Angle Identities. And even though those concepts are not emphasized in these packets, they will be quizzed and tested. There will be a question on Friday's quiz on this, so you need to pay attention to video number 7 as well. Before we get started, I'm letting you know that I'm trying a new device for this video, so I'm going to try to use the best I can. You should hear less keyboard clicks, and it's going to be more handwritten than typed, so hopefully that will help some of you who did not like all the distracting noises. And thanks to Rob Schuyler for helping me out by loaning me this piece of equipment. So we're going to talk about more trig identities. That formula sheet is packed with them. And in this lesson, we will use the identities that deal with doubling an angle. Now, we deal with this a lot more in upper level mathematics. And in this class, we're not emphasizing the understanding behind this, but rather the manipulation of the formulas. And when you take pre-calc or calculus, you will get better into why these formulas are the way that they are. In fact, you actually did some of the work to show that this happens on last night's homework with the sum and difference identities. However, we're going to just assume that we've already learned that the why and move forward with the how. So in this, we're going to be deriving the identities using this quick problem here for double angle and then for cosine. We did this last night for sine of A plus B equals sine A cosine B plus sine B cosine A. And cosine A plus B is cosine A cosine B minus sine A sine B. Now if we go back here and we say that, nope, this is going to be tricky. Sine of A, if we're going to double it, both angles are going to be A. So this would be sine A times cosine A plus sine A times cosine A again. And when you get this into be the case, you notice that we have two of them. So we end up really with 2 sine A cosine A. And if you notice that, this is the formula that's given up here. Now over here, with cosine, we have cosine A plus B equals cosine A cosine B. So when you're doing 2A, that's really the same as saying A plus A. I didn't emphasize that in the first one, but I'm going to show you that now. So if you want to pause and give it a whirl, I'm going to just proceed. So this becomes cosine A times cosine A minus sine A sine A. What that really is this is cosine. We have two of them multiplied together, so that means they're squared. Cosine A minus sine squared, two of those. So cosine squared minus sine squared. So that's this formula. The other two formulas are using the Pythagorean identity that we did last night as well. And then that's sine squared plus cosine squared equals 1. And you do some substitution, and they're going to let you do that for your homework. So tomorrow in class, if you're having trouble with that, just make sure you ask. So now that they want to verify for sine 2a using A equals 2a is 60. A is 30 and 2a is 60. So we're going to verify this. So the way we're going to verify this is that first, let me just give myself a little more space. First, we're going to think about that sine A cosine A is what that identity is equal to. And we know that the sine of 30 degrees is 1/2. And we know that the cosine of 30 degrees is 1/2. Or sorry, root 3 over 2. Not both 1/2. You guys should have known that. So this is really 2 sine of 30 times the cosine of 30 should equal the sine of 2 times 30. Come over here. And we know that 2 sine, so we have 2 times the sine of 30 is 1/2, times the cosine of 30 is square root of 3 over 2. And we want to show that that is equal to the sine of 2 times 30. So when we multiply the top, this is technically over 1. We have 2 square roots of 3 over 4. We could simplify this down. We get it equal to the square root of 3 over 2 is equal to the sine of, now let's do this multiplication. What's 2 times 30? That's 60. So what this formula has just shown is that if we use 2a being 60 degrees and we plug in the whole thing just using regular a, then we get that the sine of 2 times 30, which is the sine of 60 as we shown in the end, is equal to 2 times the sine a times cosine a, which would be 2 times 1/2 times square root of 3 over 2, which is square root of 3 over 2, and that is the same exact value we get when we do the sine of 60. Now, if you don't remember where I got those values from, it's your good old 30, 60, 90 triangle. So your 1, 2, and square root 3, and your triangle 1, 2, 3 bunnies in a cage. Now down here for this question, when we do 2 sine alpha, and they tell you that alpha is in quadrant 2, and cosine of alpha is -3/5. If alpha is in quadrant 2, if I'm going to double it and make 2 alpha, that means I'm going to double this, and we're going to get it that it could be, we double the 180, we get 360. If we double the 90, we get 180. So it means our double angle is in both quadrants 3 and 4. Now, we also get told that the cosine of alpha is -3/5. Well, that means that our original one is in quadrant 2, and we are going to use, here's alpha, we're going to use the idea of adjacent over hypotenuse, and here's x. Use the Pythagorean theorem, x squared plus 3 squared equals 25. 5 squared, I should say. I skipped a step there. And that you get x squared plus 9 equals 25. And x squared is equal to 16. So x could be plus or minus 4. In this case, we're on the side of a triangle, so we want positive 4. And sine is in quadrant 2, so we know that the sine of alpha is going to be opposite the alpha over the hypotenuse, or 4/5. And in quadrant 2, we're positive, so our answer is positive. So if we're going to use this formula, sine of 2 alpha, that means we're going to do 2 sine alpha cosine alpha to find the actual value. Now, we know this is going to be 2. Sine of alpha, we just found, was 4/5, given on this equation over here. Cosine of alpha was given to us in the problem. It's -3/5. Put this over 1 and do the multiplication. Oops, somehow I got out of the pen mode here. And we get 2 times 4 times -3, get -24 over 25. And if you notice, it's sine of an angle that's in quadrants 3 or 4, so we expect it to be negative. Now, cosine 2 alpha, it's going to be in either quadrant 3 or quadrant 4. And we need to proceed with the problem here. So we can use anything we want. If you go back to the cosine double angle formulas, there are 3 of them. If we know sine, we can use this one. If we don't know sine, we can use just this cosine one. If we don't know cosine, we could just use this bottom one with the sine. I'm going to just use the top one just to show you how it works, and since we've already have cosine of A and sine of A, we're going to plug it in that way. So a cosine of our double angle, let me switch colors so you can see which one's which. is going to be cosine of squared alpha minus sine squared alpha. Now what that really means is it is the cosine of alpha, which is negative 3/5 squared, minus the sine of alpha, which is 4/5 squared. When you square this one, you get 9/5, 9/25. When you square this, we get 16/25. And when we subtract, we get negative 7/25. Now, by knowing that cosine is negative and sine is negative, we actually know, and this question wasn't actually asked, that 2 alpha is in quadrant 3 because both the cosine and the sine are negative, and that only happens in quadrant 3. Now this piece, that's a little pre-calc for you. All right, so move on to the next page. Here are the double angle formulas again. We're going to go through the same idea. We know that the actual alpha, or your actual letter A, is in quadrant 3. That's given here, quadrant 3. And then we are given that the sine of our angle is negative 11/6. So now we have to find cosine. So before we proceed for any of these, whenever you have a sine given, you should always set up your triangle and find the third side. So if this is A down here, we know opposite A is square root of 11. The hypotenuse is 6. Remember, this negative sign just helps us figure out what quadrant we're in. We set up the Pythagorean theorem. I'm going to do it up here so that we have square root of 11 squared plus x squared, I forgot to put my x, equals 6 squared. Square root of 11 squared is just 11, plus x squared is equal to 36. You subtract 11 from both sides, we get x squared is equal to 6. So x is going to be plus or minus, when I subtract I get 25, and x is equal to 5. So our answer, oh my goodness, hold on. What a mess. All right, so we have x squared. 11 plus x squared is 36. Sorry, guys. Subtract 11, we get x squared is 25. We take the square root, and we get x is plus or minus 5. So we know that this down here is 5 or negative 5. Now we're in quadrant 3. So the next thing you need to do is think about cosine. So when you do this, we know that the cosine of A in quadrant 3 is going to be negative, and cosine is adjacent over hypotenuse, so it's negative 5/6. Okay, so now we just have to find the sine of 2A. So now going back to our formula that we have from up here, we know that this is going to be, nope, what's going on now? Okay, apparently this video has unexpectedly crashed. The conclusion of this video will be in video 7, and I will continue the conversation on this and do the half angle formula. Come here.